Okay, what would happen if we put capacitors in series and parallel? Let's take a look at series first. So here's my potential, and now I have capacitor 1, capacitor 2, capacitor 3. And as I go around this loop, I end back, so that means here's my high potential side, here's my high potential side, low potential side, high potential side, low potential side, high potential side. Back here to my low potential side. So as I move around, my total potential has to be the potential across number 1, because I've got some potential across here, plus the potential across 2, going from here to here, that's V2, and then the potential across 3 from there to there. All of those potentials have to add up. I went around in the circuit. I've got to use that energy up somewhere. So as we remember, Q on a capacitor is C times V. So let's see, I'm trying to find, so V1's going to be the charge on 1 on the capacitance of 1. So Q1, C1 plus Q2, C2 plus Q3, C3. And that's going to equal my total charge that I have on all of them divided by my total capacitance or my equivalent capacitance. So let's keep going here. What's next now? The charge that comes on this one, pushes that charge off and it goes off to the next one. That pushes the charge off and it goes on to the next one. The charge on each one is equal. So the amount of charge that gets pushed, the positive charges come around, they push that one off, then they get stuck, but then they push that same amount off here, so the charge is the same, so I can pull that off, and I end up, wrong side, and I end up with all of these Q's equaling the same, so I end up with Q equals 1 over C1 plus 1 over C2, capacitance of 2 plus 1 over the capacitance of the third one. And all of this equals Q, my total charge, because that is the total on each one of them, divided by my equivalent capacitance. The Q's go away, and you end up with something, here we go. You end up with 1 over the equivalent capacitance is simply the sum of the reciprocals. So the reciprocal of the equivalent capacitance is equal to the reciprocal of the sum of the reciprocals. It's a harmonic addition. Notice this is opposite resistors that are in motion, resistors that are in series. Wherever my there is. Opposite of resistors, these are different. So now, what about in parallel? So here I have 3 resistors in parallel at some voltage. So as we look around, they are all connected to the same side in the circuit. So you've got some charge over here. This capacitance might be a little bit bigger. It'll hold some more charge. This one holds a lot more charge. All right. 2, 3, 4. 1, 2. Now what would be my total capacitance here? So again, we go back, we start with Q equals CV. Now each one has the same voltage, but the charge, my total charge, see this only has 2, this one has 4, this one has 6, so the total charge is going to be the Q1 plus Q2 plus Q3. So my total charge is going to be my equivalent capacitance times whatever the potential is, and that's going to be the capacitance of 1 times the voltage of 1 plus the capacitance of 2 plus the voltage of 2 plus the, that's times the capacitance of 3, potential of 3. So, but because they're in parallel, V of the battery equals V1 equals V2 equals V3. The potential across each one of them is the same. That goes away. So now you end up with C1 plus C2 plus C, the capacitance of 3 times the potential, and that's the equivalent capacitance times the potential. That goes away. So the equivalent capacitance, when they are in parallel, is just the simple sum. 3. All right, if you want to get all fancy about it, it would just be in the sum of the capacitances. All right.